Welcome all, I am Chesintha, Assistant Professor, Department of Mathematics, Rathinam College of Arts and Science. Today I am going to teach you graph theory. Graph theory is a branch of mathematics. In today's lecture we are going to give an overall idea about the application and what is graph and the types of graph. Okay, let's start with an application. Here we list out some important applications regarding graph theory. Computer networks, which is the basic, the computer networks are mainly works on the based on graph theory, application of graph theory. And similarly the railway networks, any transportation network, we can find the application of graph theory. Shortest path problems are, everything is based on this subject, graph theory. When you give when you have a idea about graph theory, then it's easy to define the network and its properties and all those things. Then next we are going to check what is graph. A graph is defined as, it is an order tuple. It consists of the component V and E, where V is the vertex set and E is the edge set. Vertex is otherwise called as nodes and points. It is in a transportation we can consider it as a terminals, bus stands, and the connection between the bus terminals are roads, that is edges, where E is the edges, and edges otherwise called as lines or arcs. Then here I given 3 examples for graphs, G1, G2 and G3. G1 consists of 5 edges and 5 vertices. Similarly, G2 consists of 5 edges and 5 vertices. So, similarly, G3 also consists of 5 edges and 5 vertices. Here in G1, A, B, C, D, E are the names of the vertices, and in G2, P, Q, R, S, T are the name of the vertex. Similarly, here also G3, in G3, U, V, W, X, Y are the 5 vertex, and the lines between these vertices are called as edges. Okay. Next we are going to see what is finite graph. A finite graph is nothing but the graph which contains finite number of vertices and finite number of edges. I have written here G1 and G2, G3 are the finite graph which having 5 vertices and 5 edges. Okay, in most of the case finite graphs are takes into place. Okay. Direct graph. It is also a type of graph. In direct graph, edges are directed by arrows. The main application of directed graph is one-way traffic road. In one-way traffic road, we can we have a path from a terminal A to B, but we cannot move from B to A. Similarly, here I given a graph in which there are 5 edges and 5 vertices. A, B, C, D, E are the 5 vertices and 5 edges. And each edges is denoted having an arrow. That means the edge is from A to B. There is no edge between B to A. In this case, A and B are AB, the edge AB and BA are not same. Okay, they are different. Directed graph is also called as digraph. Okay, next. This is the application of directed graph. In one-way road, traffic flow is permitted only one direction. In this case, V1, V2 are the edge. It is different from V to V1. Okay. Okay. Next, the degree of vertex. The degree of vertex is an important concept in graph theory. The properties of graphs are based on degree, concept of degree. Okay, there are two types of degree. One is in degree and another one is out degree. Okay, degree of vertex is denoted by d of v or degree of v. That is the number of edges connected with the particular vertex. If we take the vertex v, then the number of edges connecting to that vertex is called degree of the vertex. But in directed graph, there will be two terminology, in degree and out degree. Okay. In degree of the vertex is the number of edges connecting to the vertex. Number of edges connecting to the vertex is called the in degree. Similarly, out degree of the vertex is the number of edges which are originated out of the vertex. Okay. And based on the number of degree of the vertex, we can classify the types of vertices. First one, isolated vertex. Isolated vertex is said to be, a vertex is said to be isolated if the degree of the vertex is 0. That means no edges connected to that particular vertex. Similarly, pendant vertex. Pendant vertex is a vertex which in which the degree of the vertex is 1. That is, only one edge is connected to that particular vertex. And odd vertex. If the number of if the degree of the vertex is odd, then the vertex is called odd vertex, and the degree of the vertex is even, which is even vertex. I have given an example. The same graph we consider for the definition of the directed graph. In A, for each vertex A, B, C, D, E, we are defined in degree and out degree. In degree of A is, there is no edge that is connecting to A. So, the in degree of A is 0, and one vertex is originating from A. So, the degree of out degree of A is 1. Similarly, in degree of B, there is only one edge that is pointing to B. So, the in degree is 1 and two edges are originating from B. So, the out degree is 2. Similarly, we can define in degree, out degree for C, D and E. Okay. If we consider the graph is undirected, that means no direction is defined, then the degree of A is equal to 1. That is, only one edge is inside with the A, and the degree of B is 3, because three edges are inside to the vertex B, and for C the degree is 3, and for D the degree is 3, and for E the degree is 2. Okay. There are two theorems. I just mentioning the theorem only. The theorem states that if G of VE is the directed graph, then the sum of all out degrees of all vertices is equal to the sum of in degrees of all vertices, which is equal to the number of edges in the diagram. which shows that the total number of odd degree total number of sorry. Okay. The theorem says the out degree sum of all out degrees of all vertices is equal to sum of all in degrees of all vertices, which is equal to the number of edges in the graph. The second theorem is the number of vertices of odd degree in a graph is always even. That is, the number of vertices having odd degree in a graph is always even. Okay. Then adjacency and the incidency. These are the two terms which again important in graph theory. Adjacency. Two vertices are said to be adjacent if they are connected by an edge. If there is an edge, consider an edge E from U V, then U is said to be then U and V are said to be adjacent. U is said to be adjacent to V and V is said to be adjacent from V. These 2 points are mainly for directed graph. The edge E is called incident inside with the vertex U and V. Okay. Okay, then loop and multiple edges. A loop is an edge whose starting and end vertices are equal. The edge starting and ending at the same vertex is called loop, and multiple edges. If two or more edges are joining same pair of vertices, then the edges are called multiple edges. Based on the adjacency and the loop multiple edges, the graphs are called classified into different types. I have listed out the types of graphs: simple graph, multiple graph, pseudo graph, trivial graph, null graph, complete graph, regular, weighted, bipartite and complete graph, complete bipartite graph. Okay, these are we can see in the next class.